All right, well, hello everyone, and welcome back. Today we're going to cover simple loops and good coding practices. And you'll see that both of these tools are incredibly common and incredibly useful as you learn more about programming. Okay, so goals for today. By the end of today's video, you should be able to recognize the difference between for loops, while loops, and do-while loops. We'll do some examples of each, and you'll get a better idea of what each type of loop is best used for. Next, we'll work on writing some programs that use loops to repeat code. We're also going to learn about writing code following good formatting practices. And we'll learn about how important it is to follow those good coding practices. Finally, we will look at the FizzBuzz interview question, which is actually a very common interview question that is asked to students, and we'll talk about the best ways to answer it using what we know about loops and if statements. So real quick, let's go ahead and start with the review question. So this question is asking us, what, if anything, is wrong with this code? Take a look. See if you can identify some potential issues with this code. I'd encourage you to pause the video a moment and see if you can identify the issues. Okay, so were you able to notice anything off about this code? There are two items that I would like to draw your attention to. First is this if statement. Is score single equals 100 the correct Boolean expression to use? Notice we want to compare score and 100. Remember, single equal assigns value. Double equal compares values. So in fact, you would see that if you used if score single equals 100, what would happen here is your score variable here would be assigned the value 100. So what would happen is score would be assigned the value 100. And since that if statement does not contain anything that is 0 or false, the if statement would always be read as true. And of course, that's not what we want here. We don't want to see perfect, you got 100% if our score was not 100. So the first issue is we should use if score double equals 100. That way we correctly compare the variable or the value stored in score with the number 100. Do you see anything else that might be a problem in this program? There's one more issue, and that issue is right here. Notice here, it appears that the programmer intended to have two statements associated with the if. Remember, if you have an if statement, If there are multiple statements for an if statement, we need to enclose those in braces. So here, we actually would have needed to use some curly braces to enclose such that both of those cout statements would be included with that single if statement. So second error here is the two statements need to be enclosed in curly braces. That will ensure that both of those statements are protected by that if. All right. So definitely watch out for those small items as you're practicing if statements. Single equal versus double equal is a very common thing that beginner programmers sometimes get mixed up on. So remember that the single equal sign assigns value, and the double equal sign, the equality operator, that compares values. Okay, so real quick, let's go ahead and briefly review what we learned last time. Again, we learned about if and else statements. And we saw that if statements allow us to create branches in our program. And so we could have something, have some if statement here, and then if it's true, we do a thing. And otherwise, if we're false, we return back to our program and continue on. So, for example, if it is cold, then we wear a jacket. And notice the syntax for if statements. You may remember we covered how we do not want to put a semicolon right after the parentheses of the if. Remember that the semicolon marks the end of a C++ statement. So in the case of if statements, the semicolon only goes at the end of each statement enclosed in the if. And remember, if you have multiple statements that need to be protected by an if or an else, then you need to enclose multiple statements in curly braces. All right, we also learned about Boolean operators and how these allow us to check for true or false. We learned that the assignment operator, or single equal, assigns value, double equal checks for equality. And of course, we learned our syntax for if and if else statements. And remember this last point. If a Boolean statement contains anything other than 0 or false, it will evaluate to true. All right, last things to watch out for. Once again, when using if-else statements, be careful of semicolon and braces. We also mentioned that dangling else problem. Remember that the compiler is going to pair the else statement with the nearest previous if that has not been paired with an else. So if needed, use braces to make sure your ifs and elses get matched up correctly. All right, so that concludes our review for this video. If you do have further questions on if and else statements, you might find it helpful to review our previous video. And feel free to reach out if you have further questions. You'll see that we'll continue to use if statements basically throughout this course. So it's very important that you know how to understand making decisions in programs. So let's go ahead and move on to loops. Loops are another extremely important coding tool that we will use constantly. Here are some general terms that you should be familiar with. First is a loop. Well, what is a loop? Loops are sections of code that will repeat under certain conditions. Typically, these specified conditions would be specified by a Boolean statement. Next is a counter. Very often, we want to keep track of how many times our loop has run. A counter is a variable that we increment. Here we mean adding +1, decrement is -1. So a counter is a variable that we increase or decrease each time a loop repeats. And sometimes we also use it to control the loop's execution. Sometimes we also use it to help with a calculation. And notice this note here, we need to initialize our counter variables before entering our loop. So generally you want to make sure you initialize them to 0 or whatever initial value they need to be at so that when we do math and we increment them, we won't run into errors. Another important loop term is the running total. Suppose you wanted to calculate the average of a bunch of numbers. You would use what we call the running total to keep track of the sum of all the numbers from each repetition of our loop. You could divide the sum of the numbers by the total number of numbers you read. That would give you your average. And finally, the accumulator. Also a very important variable. It keeps track of the running total of how many times our loop has run. In certain applications, we want to keep track of how many times our loop has triggered. For example, if you are coding a guessing game and you want to give the player a certain number of guesses, or if you're making a video game and you want to give the player a certain number of attempts on a level, you may need to use an accumulator to keep track of how many tries or how many times that loop has run. Okay, so now let's review the three main types of loops that we use in C++. The first type of loop is called the while loop. And the while loop will repeat as long as the Boolean expression in the parentheses is true. So for example, what if I had something like this? While Professor Erickson is hungry, and this is not actual code, this is what we call pseudocode. While Professor Erickson is hungry, then we eat a snack. Right? As long as I'm still hungry, I'm going to keep eating a snack. But notice that if I'm not hungry, then I'm going to skip eat a snack. Then I won't run at all. So the while loop will only run when the expression in those parentheses is true. And so if the statement is false, then we skip that statement. If the Boolean is false, code does not. So notice the while loop is very good to use when you are not sure whether your loop needs to run at all. I'm not sure if I will be hungry all the time. So if I'm not hungry, then I skip eat a snack and I move on to the next part of my code. And notice there's also no limit as to how many times this could run. So if I'm really hungry, this loop might run for quite a while. Next kind of loop is the do while loop. A do while loop is a while loop, but notice it is guaranteed to run at least one time. So it's a little bit of a special case of a while loop, and you use it if you always need the loop to run at least one time. A good example when you might consider using a do while loop is if you're trying to make a menu. Like maybe you always want to display a menu. Now that way, the loop will always run at least once and display the menu, ask for a choice. That way, no matter what the menu is going to display, the user might immediately choose to exit the loop, and then the loop only runs once. But a do while loop will always display, or a do while loop will always run at least one time. So we could do something like this, where we're displaying a menu, ask for a choice, and then we say while the user hasn't quit. So we keep displaying our menu until the user chooses to quit the game, and we see that in this case, the loop will always run at least one time before potentially exiting. Last type of loop is called the for loop, and for loops are also a very common and important type of loop. So a for loop is very useful when you know exactly how many times your loop should run. Because the for loop has built-in tools to help increment. So if we know we want to output all numbers between 0 and 100. So if we wanted to output all the numbers between 0 and 100, we could use a for loop to make a loop that will run exactly 100 times for outputting those numbers. So let's now take a closer look at each kind of loop. So we'll look at exactly how we program these in C++, and then we'll practice doing a few examples. First is a while loop. And so what a while loop does is first, it immediately checks whether the Boolean condition is true. So it's going to immediately check some Boolean expression, and it's going to see, okay, is this expression true or false? For example, is Professor Erickson hungry? If that statement is true, then the loop statements will execute. So for example, while Professor Erickson is hungry, give her a snack. And then notice what happens here is if the Boolean expression is false, the loop doesn't run at all. So if I'm not hungry, then I don't even run the statements, I just pass straight through to the next section of my program. But then the other thing that happens is that the loop will keep running until the Boolean condition becomes false. So what this means is the loop could repeat any number of times until the Boolean becomes false. And also, we know that there needs to be some code. There needs to be some code inside our loop, which eventually becomes false, or eventually makes the Boolean false. Otherwise, if there's no code in our loop that makes this become false, then we will just keep looping around endlessly in a while loop. Let's take a look at an example. And you'll notice in our example that we use syntax as shown here, kind of similar to an if statement, where we use while, and then all the statements we want to repeat are either a single line can be on its own with a semicolon. If we have multiple lines, we enclose them in braces. So here's a quick example. So here we have our usual include headers. All right, so in our main function, you see we have some counting variable called countdown, or a counter. And notice we ask the user, how many greetings do you want? So the user tells us how many times a loop should repeat. And then you'll see, here comes our while loop. So inside the while loop, notice we have while countdown is greater than 0. So basically what happens here is as long as countdown is greater than 0, we're going to output hello. And then notice here we decrease countdown by 1 each time the loop runs. Well, why do we need to do that? Well, notice if we don't decrease countdown each time we run, then this loop will never have its Boolean become false. We want to make sure this loop will output the correct number of greetings in this case. And we also want to make sure that that loop will eventually stop when it's supposed to. And so we output hello until our countdown reaches 0. Let's try just briefly walking through that. So for example, suppose countdown was 3. Right? So if we ask the user, they told us countdown was 3, then while countdown is greater than 0, 3 is greater than 0, right? So our loop is true. We'd go ahead and run. So when countdown initially were 3, we get a hello, right? And then notice countdown becomes countdown minus 1, so countdown becomes 2. So here, for our first loop iteration, countdown was 3, we get a hello. Now countdown is 2. Well, 2 is still greater than 0, so we output another hello. Notice it's still on the same line. Iteration number 2, we get our second hello. And then countdown is decreased to 1. 1 is still greater than 0, so our third iteration triggers. We get a third hello. Then countdown becomes 0 because 1 minus 1 is 0. So finally, while 0 is greater than 0, well, 0 is not greater than 0. So notice the loop stops after 3 iterations. So in this case, we were able to output 3 hellos by setting countdown initially to 3. And finally, when our program's done, our loop ends and we output our last message. Also notice another thing. What happens if our user gives us a negative number? Will the loop run? Well, notice a negative number is not greater than 0. So if our user gives us a negative number for countdown, the loop won't run at all. Let's briefly pull up this example in Sea Lion so that we can briefly demonstrate this for real. So here you can see our example code for countdown. So we've got countdown, how many greetings do we want? And notice, as long as countdown is greater than 0, then we decrease countdown and we output our hello. So let's go ahead and try running this one. Let's go ahead and hit run. So once again, we are asked, how many greetings do we want? So maybe we want 5. Notice we get hello, 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 hello. We get a total of 5 runs. And then once again, if we wanted 0 greetings, notice we don't get any. And similarly, if we want -3 greetings, notice since countdown is not greater than 0, we don't run at all. All right, and just for fun, another strategy, if you're having a little bit of trouble, you want to sort of watch what's happening in your loop, you can also add a little bit of code to help you keep track of what's happening. So for example, we could say something like this. We could say is currently so notice here, I can output the current value of countdown. Then I output my hello and just do another new line. And then notice I can do something like this. Notice if I run this loop again, now I can more easily see what's happening in that loop. So now if I say, for example, I want 3 greetings, notice what happens. Countdown is initially 3. We get our hello. Countdown's decreased to 2. That's our first iteration. Then countdown is currently 2. We get our hello. Then countdown has been decreased to 1. Countdown is currently 1. Hello. Countdown has been decreased to 0, and our loop stops. Often one of the best ways to learn is just by playing with these examples and trying to modify them. So key takeaways here. As we saw, while loop syntax is similar to if-else. We put the statements we want to repeat in braces. If you have just one statement that you want to repeat, you do not have to use braces. Notice once again, there's no semicolon right after the parentheses and the while, but we do use semicolons after each statement inside our while loop. Let's try a code sense question now. Take a look at this loop. We got another while loop here. What will this loop do? Take a moment and think about it. All right, well, what did you think? Notice we declare a value x, right? We have some counting variable x, and as long as x is not equal to 12, then we output x. As long as x is not equal to 12, we output x, and then we increase x by 2. Okay, well, let's just try tracking what's happening. So initially, x is 1, right? So initially we have x is equal to 1. And then x is not equal to 12. So what do? Well, we output just the number 1. That's nice. And then we increase x to 3. Now x is 3. We output x. Then we increase x to 5, right? Then we output 5, increase x to 7. And maybe you're seeing what's happening here, right? 1, 3, 5, 7, 9. Then x becomes 11. But wait a minute. Does x ever become 12? Yeah, look what happens here. This loop is going to output odd numbers. Notice, does x not equal to 12 ever become false? So in this case, this loop is actually going to do choice B. It is going to output odd numbers continuously. Let's go ahead and demonstrate this in Sea Lion. All right, so here's our program. So again, we start out with x is 1, and notice if I were to run this thing, look what happens. Like in just a matter of seconds, my x has become 63,000. And I could let this thing run forever if I wanted. This would sit here and run and run and run, and eventually my computer would probably run out of memory, or my laptop battery would die, and then this thing would have to stop. But otherwise, this would run forever, because the while statement is always going to be true. How could we fix this? How could we make this loop stop? Well, there's a couple things we could do. Maybe instead of while x is not equal to 12, maybe we say while x is less than. Right? If we do that, then notice we just get numbers 1 through 11. So be very careful how you design these Boolean statements, because notice you need to have some code in your while loop that makes this Boolean statement false. So it turns out there's a name for those loops that run forever. We call them infinite loops. So loops that never stop are called infinite loops. As we mentioned, the body of our loop should contain some line that will eventually make our Boolean expression become false. And in our example, we saw that one way we could do this is change this while expression to while x is less than 12. Okay, so definitely take a moment to try practicing that sample code. Now we'll move on to do-while loops. So as we mentioned before, a do-while loop is guaranteed to always run at least once. So it's set up a little differently. You see the statements will always execute at least once. So first we run our statements, then we check our Boolean expression. And so we find out, okay, is this expression still true? If it's true, then we run again. Otherwise, if our Boolean statement becomes false, then we exit the loop. One thing to notice here is since that while expression comes at the end of this whole statement, there actually is a semicolon at the end of the do while expression. So just a small difference between do while and while loops. And notice the syntax. We have the word do, we put our statements inside braces, and then while, then we put the Boolean expression inside those parentheses. Let's look at a quick example. So as we mentioned, this loop will be guaranteed to run at least one time. So here we declare some character that will hold an answer from a user. So we declare a character, and then immediately we're like, hello, do you want another greeting? Press Y for yes and for no. Here we input the user's greeting. So the user gets a chance to give their answer. And notice here, we repeat as long as the user answers with capital Y or lowercase y. So as long as we say either big yes, little yes, we keep running. Otherwise, the loop ends, we get a goodbye. Let's briefly demonstrate this one in C-line. So here's our do while loop. Again, same code as before. So let's go ahead and run this. And we see immediately our loop executes. Hello, do you want another greeting? Maybe I just wanted one. If I push anything other than yes, my loop ends. So notice, even if I put something random in here, what if I put G, right? Something wrong. Notice, as long as I answer not yes, the loop will stop. But if I put Y for yes, big Y for yes, it's going to keep going until I give it something else. Okay, so once again, just to summarize, do-while loops are a special case of while loop guaranteed to run at least one time. And be careful of the small differences in syntax compared to a normal while loop. Okay, next, let's go ahead and move on to for loops. For loops are extremely common, and we'll see later when we cover things like arrays. For loops are incredibly useful in C++. So here's how a for loop works. You'll notice that the for loop actually contains three things. inside the parentheses. So we have the word for, parentheses, there's 3 different things separated by semicolons. And then inside, we have a statement, or if we have curly braces, we could put multiple statements. So this initialization is first performed. So this runs at the beginning when the loop first starts. And often the initialization is used to initialize a counting variable. Then we evaluate the test expression. This is the Boolean statement. And again, the Boolean statement will decide whether our loop keeps running or how long to run. And so if that Boolean statement is true, then we execute the statement inside the loop. Otherwise, if this test expression becomes false, then we end the loop. So the Boolean statement inside that test expression that decides whether to keep running the loop. And then finally, the last part of the for loop is this update. So update is often used to increment a counting variable. And one thing to note, once again, is that once update is completed, then we reevaluate test. So basically, we continue, we go back to step 2, and the loop repeats. So we check the test expression. If we're still true, statement runs. Then we update whatever's in statement 3. Let's look at a quick example. So here's a very simple for loop. And notice we have our initialization statement. Our initialization statement sets count equals 1. So that's the first part of our for loop. We set count to 1. Notice that count was already declared prior to the for loop. And the next part is our test expression. So again, that's a Boolean statement. And notice here, we're checking whether count is less than or equal to 5. And then assuming x is less than or equal to 5, then we run the statement inside our for loop. So we run, if count is less than or equal to 5, we output hello in this case. And then, once we're finished, then we run our last expression, our update expression. So here, we increment our counting variable. Basically, this for loop has a counter built in so that, in this case, we are outputting the word hello count number of times. This for loop will output hello count times. In this case, count is less than or equal to 5, so in this case, we'll get 5 hellos. Let's briefly demonstrate this. So here's our for loop, and notice we declare count, then we have our for loop and our statement. So if we go ahead and run this, there we go. We get hello, 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 hello. All right, so if we'd like, we could modify our for loop to be something like this, where notice we could use count to also keep track of how many times our loop has run. So here, we ran one time, we output the value of count, which is 1, then we do hello, right? So here we could also say if we prefer count is currently equal to, notice here, count is currently equal to 1, hello. Then count is currently equal to 2, because we incremented it, we get hello again. And then notice, once count is incremented to 6, then we stop running. Notice we can also increase that Boolean such that if we wanted, we can count all the way to 100. Alternatively, we could start at 100. We could make count greater than or equal to 0, and we could go backwards. We could do count minus minus. So notice if we did that, then we would go in reverse order. Does it matter whether we declare the counting variable inside or outside the for loop? When and why would that matter? Take a moment and think about it. So here's what happens. This is why you want to be careful about where you declare variables. Remember what we said about declaring variables. If you declare a variable, that variable only exists within the braces where that variable was declared. So again, where the variable exists, that is called the scope of a variable. So notice if I declare a variable, if I declare a variable in my main function, like count right here, count will exist within the braces of my main function. However, if I declare count only within my for loop, then count will only exist within the braces of that for loop. So it does matter whether you declare the counting variable inside or outside the loop. Here's the general rule. If you only need the counting variable inside the loop, you can declare it as part of the for loop. So we might only need count to output hellos, and then we're completely done. So if that's the case, just declare it in the for loop. However, if you need the program to use that count variable later, so if you need to know count later on, we need to know what count is after the for loop has finished, then we need to declare that variable outside the for loop. That will ensure count still exists after the loop ends. So this is a very important point. Please make sure you remember. If I declare count here, count will only exist while the for loop is running. And we won't be able to access count once the loop is finished. So be careful. Make sure that if you do need that counting variable later, declare it outside your loop. You'll notice CLion will also give you an error if you try to access a variable that doesn't exist. So count is still available after the loop ends. So if I run this, you'll see there's no problem. Oh, but look at that. We didn't output hello 6 times. We only outputted 5 times, right? So in this case, because of count plus plus, we actually need to say count minus 1 here because count had been incremented to 6 in order to stop the loop. But notice what happens if I do not declare count here. Immediately, CLion gets a little annoyed, right? Because I need to declare count. And then here, if I declare count inside the loop, but, oh, wait a minute. See what happens? Count will not be available after the loop ends if count was declared in the loop. So here, since I declared count inside there, count only exists during my for loop. And notice I'm getting that error message, undeclared identifier, because count does not exist after the loop has ended. So once again, just to summarize that, what we were referring to just now was what's called scope. Scope is the section of code where a variable is valid, or where a variable exists. And a block is a section of code enclosed by braces. If I declare some variable I inside my for loop, that variable I only exists in my for loop. If I declare a variable sum out here, then sum will exist in the curly braces where it was declared. And notice sum would also be available inside the for loop as well. So as long as I have declared something within the curly braces, it will be available throughout the area enclosed by curly braces. So that leads us to these two important rules. First rule, if you declare a variable inside a set of braces, that variable only exists within those braces. We say in formal terms that that variable is considered local to the braces. So in this case, in the example I drew, sum is local to main because it exists in main's braces. And then I is local to the for loop because I will only exist in that for loop. What that means is that if we declare a variable inside the for loop statement, like this letter I, that letter I is local to the loop, and it will only exist inside the loop. Couple other notes about for loops. You're allowed to have multiple statements inside the initialization. Just separate them with a comma. And notice the initialization expression does end with a semicolon. You can also leave the initialization statement completely blank if you had initialized the variables you need earlier. Another note, you can also have multiple statements inside the update expression. So notice you just separate the statements with a comma. And finally, just a few more points as we wrap up our discussion of loops. First point, as much as possible, write code yourself. The best way to improve at loops and programming is to write more loops and write more programs. The more you practice, the easier coding will become. I can't emphasize enough how helpful it is to practice. Programming truly is a skill that requires practice to master, and you need to be patient and give yourself that time. So let's try a few examples for extra practice and to help you see, how we could actually practice this stuff. And I would encourage you to first try these on your own and then compare your solution to mine. You could even take it a step further and modify these examples beyond what the initial instruction was. That's one of the best ways to improve at programming. So let's try a first example. Here we want to write a program which will ask the user for a number between 1 and 5 inclusive. So basically the number needs to be greater than or equal to 1 and less than or equal to 5, right? If the user enters a number which is not between 1 and 5, the program should keep asking the user until a valid input is received. So, question is, what kind of loop should we use, and how do we write this program? Try pausing the video and giving this a try. Well, what kind of loop should we use? Well, do we know how many times this loop needs to run? So, based on that reasoning, probably not a for loop. Because remember, for loop, you want to know how many times you need that loop to run. Does the loop have to run at least once? Well, maybe depending on how we design it. So in this case, probably a while loop would be best. It can run 0 or as many times as needed. Basically, our plan for this program could be that we ask the user for a number, and then while the number is not valid, we could ask again and get a new number. That's one way that we could write this program. Let's go ahead and code it up real quick. We have a new blank main function, so we need to ask the user for a number. So I'm just going to first declare a variable for int user number. And we ask the user, enter a number between 1 and 5 inclusive. Then take in the user's number from the keyboard. And here comes our loop. So we use a loop to check whether the number is valid and keep asking for valid number. So we can say while user number, so if they give us something that is not within the desired range, ask for a valid number again. So here we could say, okay, fine. That number you gave is not between 1 and 5 inclusive. So we can say, please enter another number. So notice this loop is going to keep running until we get a good number. So at the end, I'll just have another statement so we can see what number they finally gave us. So once again, declare a variable to hold the number, ask the user, and then as long as the user's number is not within our desired range, so as long as we're less than 1 or greater than 5, then we get the error message, please enter another number, and we keep repeating until they give us the number we want. So let's go ahead and run this, and you see, enter a number between 1 and 5. I'm going to be mean and give it 10. 10 is not between 1 and 5. Please enter another number. Not between 1 and 5. Please enter another number. So, see, I can be a real jerk, but this program is going to stubbornly insist that I give it a valid number, right? So finally, if I give it number 5, it will take 5 and end. Write a program which will output the numbers 0 to 100 to the screen with each number on a new line. What kind of loop should we use, and how do we write this program? Well, notice we know how many times this program needs to run. We can use a for loop. For loop might be the most convenient way. Alternatively, a while loop could also work. Let's briefly code this up. Basically, we declare a variable to hold a number. We initialize it to 0. And then we start our loop. So we could say while number is less than or equal to 100, we output the number, and then we increment our number. Or we could just use a for loop, starting at 0, number is less than or equal to 100, number plus plus. Notice that one would actually be even less code because for loop would actually need just one line of code inside. And then notice we can just write a for loop. And there we go. So let's go ahead and run this. And you see we get the numbers 0 through 100. If I wanted to go backwards, well, I could start with numbers 100. Then we could say number is greater than or equal to 0. And then And then I could do number minus minus. And notice if I do that, then I go in reverse. I could also do number minus equals 2 if I want to do steps of 2, and so on. So a couple other small notes about increment and decrement operators. In for loops, we often use plus plus and minus minus to help increment or decrement. Remember, C++ means C equals C plus 1. So same deal here, right? Plus plus will add 1. And then minus minus is the same as writing count equals count minus 1. And so you can actually just say, for example, countdown plus plus to tell the program to increment countdown by 1. So these are extremely common in loops. And also notice that there's 2 versions of these increment operators. So there's what's called prefix and postfix. So notice in postfix, plus plus is at the end of the number. So what happens if value is 12, we display 12, but then we update val equals val plus 1, so 12 becomes 13 after the 12 is outputted. So now val is 13. So if I say plus plus val, notice what happens here is the plus 1 happens before we output val. So in this case, the output will be 14 because first we add 1 to 13, then we display it on the screen. So notice that the location of the plus plus influences when that plus plus happens because the statement happens from left to right. Okay, so finally, let's finish up with the FizzBuzz interview question. So the FizzBuzz interview question is a very common interview question, and it's really a favorite interview question because of a few reasons. First, there's many possible approaches. Every programmer should know how to write this program. It's considered an easy interview question. FizzBuzz also helps you see the programming style of the candidate. Do you use a more clever approach versus a brute force approach? Do you really understand how to program? Also, of course, during a programming interview, you might be coding on the spot in front of people, so they want to see how do you work under pressure, and you care about clean code and using good practices. So let's take a look at the FizzBuzz question. So the FizzBuzz interview question asks the following. Write a program that prints the numbers from 0 to 100 to the screen with the following conditions. So if the number is a multiple of 3, here, number 3, you print you print fizz instead of the number. For multiples of 5, you print buzz instead of the number. And if you're a multiple of 3 and 5, you output FizzBuzz. So it's a fairly simple question, but you'll see that there are several different ways we could approach this. Here's what I call the brute force approach. So in this case, notice that we write a for loop. So here we're looking at for all numbers, or for each number between 0 and 100. Notice what we're going to do. If we are a multiple of, or in this case, if we are not multiples of 3 and 5, then we just output the number. And then here we're checking if we are just a multiple of 3, then we output fizz. And then if we're a multiple of 5, output buzz. And then else, we must be a multiple of 3 and 5, and then we output FizzBuzz. So this program does get the job done, but notice that there's a lot of code here, and if we needed to add more conditions, this code might get pretty ugly pretty fast. Checking every possible case in this way could become tedious. So the program is a correct way, but it requires a lot of code. And if somebody asked you to also output bang when you have a multiple of 7, you would have to go back and modify every single one of these if conditions in order to correctly change every possible case. So I call this a brute force approach because you're forcing yourself to check every possible case. You're not taking any clever shortcuts. Well, what if we instead try a clever approach? The clever approach utilizes if statements. By utilizing if statements, we can write cleaner, more efficient code. And more scalable code, too, you'll see. So in the clever approach, we begin our for loop like before, and then notice what we do here. If we are not multiples of 3 or 5, notice again we're using modulus here to check for multiples, so if I divided by 5 doesn't have a remainder, then we know that we can check for multiples. So here, if we're not a multiple of 3 or 5, then we output the number. Notice if we're a multiple of 3, output fizz. And if we're a multiple of 5, output buzz. Well, wait a minute. How do we check whether we're a multiple of 3 and 5? Well, if we are a multiple of 3 and 5, both if statements will trigger. So notice that this is actually a much more efficient way to write the program because there's a lot less code, and notice FizzBuzz will happen automatically if the fizz and the buzz if statements trigger. So this is what's called the clever approach. And I recommend that you really practice and understand this clever approach because if you were doing a coding interview, this is most likely the approach that would land you the job. This approach shows that you understand if statements and that you understand how to write very clean code. So once again, the clever approach is a more elegant solution. It shows that you really understand how if statements work, and it's much easier to add more conditions. All right, so let's briefly share more hint related to FizzBuzz and related to a question that I like to give on homework assignments. Suppose you want to write a program which outputs the numbers 0 through 100, separated by a new line with the following conditions. If the number is a multiple of 2, you output abra to the screen. If the number is a multiple of 3, you output cadabra instead of the number. If the number is a multiple of 4, you output alakazam to the screen. Notice if the number is not a multiple of 2, 3, or 4, you just output the number with no additional text. If we're a multiple of both 2 and 3, the output should be abracadabra, but if the conditions for alakazam are met, only alakazam should be outputted, and nothing else should trigger. So the approach here is similar to FizzBuzz. Notice we can use modulus 2, modulus 3, and modulus 4 to check for multiples of 2, 3, or 4. So if you use if statements, you can check for each multiple. The tricky question here is this last condition. How do we make sure that if alakazam happens, nothing else triggers? Here's a hint. What about an if-else statement? Remember, in an if statement, the statement protected by the if will only run if the if statement is true. So one approach to write this program is to first, start your for loop, and inside your for loop, you can check if we have a multiple of 4. If the conditions for alakazam are met, only alakazam should trigger. If we're a number multiple of 4, we output alakazam, right? And then we put everything else separate. So notice, if we use an approach like this, if alakazam triggers, nothing else will happen. For that number. Otherwise, we can output the other conditions. So keep this in mind. Notice how cleverly designed if and else statements can make programs a lot easier to write and to modify. All right, so lastly, let's go ahead and end with a brief discussion of programming style. So first question for you, which of these programs uses better style? Do you prefer program number 1 or program number 2? Which one is easier to read? Which one can you more easily tell what's happening? Most likely program number 2, right? Notice it's easier to read, easier to see braces and indents. It's also easier to edit if you need to make changes. So it turns out, for programmers, style is a big deal. So it's such a big deal that software companies even have standards so that everybody's code looks the same and follows the same practices. This is so important. If you do not code with good style, you will appear unprofessional and inexperienced, even if your code is correct. Don't be that person. You want to develop very good programming style. Develop good habits now. I would hate for you to not be able to get a job because you interviewed with bad programming style. Believe it or not, programmers are so picky about following good programming style and having readable code that if you have bad programming style, that may make the difference between you getting the job or not. So here's a general programming style checklist that I recommend you follow. And in fact, if you're completing assignments for this class, you will need to follow this checklist. You need to follow this checklist on assignments. So please make sure from now on that you follow these rules. They're very good practices, very important to develop these good habits. So style checklist. Add white space to make your code readable. So you don't need to squish everything into as little space as possible. Spread your code out, make it easier to read. Skip lines between groups of statements that do different things. Also indent statements within statements, such as inside an if statement. You indent. Right? Within braces or within if statements and for loops, you need to indent. Also, you indent within braces and place each brace on its own line. There's another way of doing braces we'll talk about in just a moment. Also, comments. We talked about comments previously. Use comments to explain what you're doing. You don't have to comment every line of code. But make it clear what you're doing. And this is especially important if you're doing something kind of non-standard or something that took you a long time to figure out. Next one, use self-commenting code, such as variable names that describe the value. Make it easy to tell what your code is trying to do. Next one, put names of constants in capital letters. We'll cover more on constants later. If you have a for loop, start the for loop's counter at 0. This will be important when we cover arrays. Also, easy to maintain solution is preferable compared to a clever but complex solution. So Better to make a solution that's easy to maintain and clear than being overly fancy and confusing. Next one in C Lion, you can use Control-Alt-L to auto-format your code. So C Lion can actually help you improve your code. And last item, we'll cover this more later on, but we want to avoid using global variables in this class. Global variables are variables declared outside the main function. So generally, we do not do this in our class, and we'll learn more about that later on. For now, you do not want to declare variables outside main. For our purposes, you should always declare your variables inside the main function or inside another function. So definitely review this checklist before you submit assignments and programs, and it will help you develop better programming practices. Another note about braces, some programmers and C Lion will put the first brace next to the thing that created it. So in this case, note we can also put our first brace right next to the main function, or we can put on the line immediately after. So both of these practices are what I call socially acceptable. Let's do a quick example before we end for today. How could we clean up this code? Notice we got some variables here, and we have our main function with no indent. Notice that we have multiple statements on the same line. We have long lines of code. You could try putting this code into C Lion. And using Control-Alt-L to format. You'll see that that might make quite a bit of difference on this program. Okay, so you can see I just copy pasted the code into C Lion, and it's pretty messy, right? But if I select the code and I do Control-Alt-L, notice that C Lion already automatically added some indents. It added some spaces, but notice it didn't move these variables inside my main. Remember, right now these variables are declared outside main, which is global variables. I do not want that. I'm going to put them inside my main function. And notice I can add space between my lines to make it a little easier to read. Notice how much easier it is to read this code when we follow good programming practices. All right, so here's an example of how that code could look when it's all cleaned up. So notice we indented within the main function. We also made variables local to main. They were declared outside of main before, so we put them inside. We put braces on their own lines. And we also indented and we added white space. Notice how much easier it is to read this program and understand what it's doing. Please do your best to follow these good coding practices. All right, so that concludes today's video on loops and good coding practices. So I highly recommend that you take the time to really recognize and practice when to use each different loop. So make sure you know the differences between for loops, while loops, do while loops, and when to use each. Also, make sure you start getting comfortable actually writing programs which use loops to repeat code. I highly recommend you try going back through and playing with those examples we did. Finally, remember to write code following good code formatting practices, and try practicing that FizzBuzz interview question. Make sure you really understand the clever approach and why that clever approach is more effective. All right, well, thanks everyone for joining the fun with this video, and we will see you in the next one. Feel free to reach out if you have any questions.